In this video, we're going to go over how to derive the weight and mass equation, as well as how to calculate using that equation. So first, we collected some data based on various objects, and we collected the data of these objects using a triple beam balance to measure their mass, and then we use a spring scale to measure their weight. So having these two sets of data, we were able then to graph them. So I plugged these data into Desmos, and then here is the graph on Desmos. Now, if we look at this graph, you'll notice that it is a straight line. So on the X right here is mass, and on the Y here is weight. And then we also got a slope here that was about 9.96. So what this graph tells me is that as mass increases on Earth, the weight of the object increases. And the slope that we get here, I'm going to round it. It's about 10 newtons per kilogram. Okay. And then using our slope-intercept equation, y equals mx plus b, we can see that the weight, W for weight, is equal to this is the slope, 10 times x is the mass, which is the x variable. B is going to be 0 because there's no y-intercept. So it's going to be, I'm going to just switch the mass and the slope here. So it's going to be times the mass, the weight equals the mass times g. So this is the weight, and that's measured in newtons. This is mass measured in kilograms, okay? And g is called the gravitational field strength. The units are newtons per kilogram. Okay. So this right here is called the gravitational field strength. Okay. So here's our equation. If you want to calculate for mass, you just take m equals the weight divided by g. If you're looking for the gravitational field of another planet, you do the same experiment, and then you can take the weight divided by the mass, and that would give you the gravitational field strength. It's helpful to know a couple numbers that you might see in problems. One is the gravitational field strength of the Earth. And on Earth, it is 9.81 newtons per kilogram. And on the Moon, it is 1.62 newtons per kilogram. Okay. So now we can work through some problems. So let's say that person A weighs 390 newtons. Okay. And we want to calculate the mass. So to calculate the mass, we take the weight divided by the gravitational field strength. So 390 newtons divided by 9.81, and we get 39.8 kilograms. Okay. So just to review here, the mass of an object doesn't change if you go to another location, but the weight of an object can change if you go to another planet where the gravitational field is different. So this right here tells you the gravitational field strength. So if you went, this person A weighs 390, goes to the Moon, their weight would be much less. Okay, let's look at another problem. Let's say person B's mass is 55 kilograms, and we want to find their weight. Okay, so their weight on Earth is going to be 55 times 9.81. Okay, and we get 540 newtons. All right, now let's take a look at an object weighs 960 newtons on Earth. Okay, and we want to calculate its mass and weight on planet X. Okay, so now we're looking for mass, okay, and weight. All right, and we're looking at a imaginary planet, planet X. Okay, and we're given that planet X has a gravitational field of 7.24 newtons per kilogram. Okay. So to calculate the mass, we're going to take the weight divided by g. So the weight is 960 newtons divided by 9.81, and we get 97.9 kilograms. That is this object's mass on Earth, but also on planet X or anywhere else in the universe. Because the mass of an object is just the amount of matter in an object, the amount of atoms and molecules, so that does not change when you go to another location. However, the weight will change, will be different. So to calculate the weight of this object on planet X, it's going to be the mass times gravitational field on that planet. So it's going to be 97.9. Remember, the mass does not change, and the gravitational field is 7.24 newtons per kilogram, and we get 709 newtons.